Welcome to the deep dive.
Wow.
We take the source material you're interested in and pull out the key insights for you.
Yep. Our mission is basically to get you up to speed quickly on the topics you send our way.
And today, we're digging into some, well, foundational algebraic stuff. Specifically, combining fractions, the ones with integer denominators, and getting comfortable with brackets. Using them, removing them.
The source material you shared lays out the rules really clearly with examples, too. It's all about simplification, really.
Taking these potentially complex expressions and making them, easier to handle. Okay, so where do we start?
Let's kick off with combining algebraic fractions. It's interesting because fundamentally it works just like arithmetic fractions you learned way back when.
Ah, right. So the main thing is finding that common denominator.
Exactly. You need the least common multiple, the LCM of the denominators you're working with.
The smallest number they all divide into nicely.
Precisely. The source gives a good, simple example. X over 2 plus x over 3. Denominators are 2 and 3.
Okay, so the LCM there is 6.
Right. So you convert each fraction. X over 2 becomes 3x over 6, and x over 3 becomes 2x over 6.
And then you just add the tops.
Add numerators, yeah. So you get 3x plus 2x all over 6.
Which simplifies down to 5x over 6. Makes sense. Same principle, just with variables involved.
Okay, so from combining terms across fractions, the source material then shifts focus to keeping terms together. That's where brackets come in.
Ah, brackets. They're like organizational tools, aren't they?
Totally. They group things so you know if a whole chunk is being added or maybe subtracted or multiplied by something else.
Like those examples, 2a plus 7b plus 93b plus 8, or multiplying like 4x times x8y. They show what belongs together.
And there are specific rules for putting them in and taking them out. Let's talk inserting them first.
Okay.
Rule 1. If you're putting terms inside a bracket and there's a plus sign right before it, nothing changes inside. The signs stay as they were.
So like 4x plus 3y 5z8 could just become 4x plus 3y 5z8.
Exactly. Easy enough. But rule 2 is the crucial one. If you put a minus sign before the bracket.
Yeah, I remember this being tricky. You have to flip the signs, right?
Every single one inside the bracket. It's like you're factoring out a -1. So that example, 2a, 4b, 9c plus 8 becomes 2a, 4b plus 9c8. See, the 9 of 4b became plus 4b inside, 9 of 9c became plus 9c, plus 8 became -8.
Right. That minus sign outside governs everything you tuck inside.
Yeah.
Okay. And what about taking them out? Similar logic.
Pretty much the reverse.
Yeah.
If there's a plus sign, no sign at all before the bracket, just drop the brackets. Signs inside stay the same.
So 4x plus 2y plus 7z9 is just 4x plus 2y plus 7z9.
Simple, but again, the minus sign is the one to watch. A minus before the bracket you're removing means that minus applies to everything that was inside.
So you flip all the signs as you remove the bracket.
You got it. 3a squared, 2a plus 4b, 7. When you remove the bracket, it becomes 3a squared, then -2a, then -4b, and plus 7.
Okay, flips the sign of each term. And what if there's a term multiplying the bracket, like 3x times x squared 5 by 7?
Ah, distribution. You multiply that term outside the 3x, in this case, by every single term inside the bracket.
Got it. So 3x times x squared is 3x cubed.
Yep.
0.3x times -5x is -15x squared. And 3x times -7 is -21x. So 3x cubed, 15x squared, 21x.
Exactly. That's the distributive property in action.
Now, the course mentioned nested brackets, too, like brackets inside brackets.
Yeah, sometimes expressions get layered. There's a standard order for dealing with that. You always work from the inside out.
Inside out. Okay, in the order of types.
Usually it's the bar or vinculum first, if that's there, then round brackets, or parentheses, then curly braces, and finally square brackets.
Okay, inner to outer. Can we maybe walk through one? That example looked a bit intense.
Sure, let's use the one from the source, a 2b plus c, 2ab.
Okay, deep breath. Innermost is the round bracket, 2ab.
Right, and look, right before it, there's a minus sign, c minus 2ab.
Ah, so when we remove that bracket, the signs flip. It becomes c2a plus b.
Exactly. So now the expression inside the curly braces is c2a plus b.
Okay, next layer out is the curly brace. What's before it?
We have 2b plus c2a plus b, so just a plus sign.
Meaning we can just drop the curly braces and the signs stay the same.
Yep. So inside the square brackets, we now have 2b plus c2a plus b. We can simplify that a bit, right? Combine the b terms.
Oh, yeah. 2b plus b is 3b. So it's 3b plus c2a inside the square brackets now.
Perfect. Now the final layer, the square bracket itself. And look what's right in front of it.
Another minus sign, a minus 3b plus c2a.
So Rule applies again. Remove the square bracket, flip every sign inside.
Okay, so it becomes negative 3b minus c and plus 2a.
Right. Now put it all together. We had the a at the very start. So it's a 3bc plus 2a.
And then combine the a terms. A plus 2a is 3a, so the final simplified form is 3a, 3bc.
And there you have it. It looks complicated initially, but following the rules step by step makes it manageable.
So really, the big takeaway for you, the listener, is that these rules using the LCM for fractions, handling brackets systematically, especially that inside-out rule for nested ones, they give you a clear pathway.
Yeah, they turn something that looks like, well, a mess, into something clean and much easier to work with. It's about bringing order to it.
It really is.
Okay.
So here's a final thought. If dealing with those nested brackets is like peeling an onion layer by layer in a specific order, where else might that idea apply? Maybe in problems you face that aren't math at all. Thinking about the layers in the right order to tackle them, could that unlock clarity elsewhere? Something to chew on.